Okay, let's get started. Our goal is 250, and we are going to start from 214, right? Which is this problem. So what is this problem about? Yeah, undirected connected graph of n nodes. So basically, we are given a graph, and as the first example says, we are going to have a graph like this. So we have 4 nodes in the first graph, right? 0, 1, 2, 3. And the node 0 connected to all 3 nodes. And what is the shortest path that visits every node? So let's see. We can start from this node. 1, 2, 3, 4. The length is 4, right? I think this is the shortest length. Let's try another one. If we start from node 0, 1, 2, 3, 4, 5, 6, right? It's worse. Okay, how do we solve this problem? Let me do some thinking here. So the data range is quite small, right? It's 12. That means we can have the complexity as 2 to the power of n, right? This time complexity is good for us. And we can develop such a function, right? And this function will take the current node, right? And the current node's parent, we can call it last, right? And this function will calculate if we start with current node, which is P, if we start from this node, and what is the shortest path to visit all its subnodes, right? And how are we going to calculate this function? So we are going to do it recursively, right? And for each of the current nodes children, we are going to use this same method on each of the child, right? So for each child, we're going to calculate the length to visit that child's or sub trees, right? And we are going to add all those values together, right? To visit one child, first we need to arrive on that child. That is one step. And after visit all that child's sub tree, we're going to go back to the current node. That is another step, right? So the total is, let's say the initial value of total is 0. Then we are going to add the subchilds and also a extra 2 steps, right? And the initial node can be either of the nodes in this graph. So in the main function, we are going to iterate through all the nodes, right? And calculate the length for each node. Right? Since it is the first node, we can define the last node, which is its parent, as -1, right? And we are going to choose the shortest length. Let's see if we did it correctly. BFS. Interesting. Most people use BFS, and the last time I solved this problem is also using BFS. But here we are using, what is this? It is a DFS, right? I'm wondering how to solve this problem by using BFS. I actually don't remember how I did this problem. All right, so I have Oh, so this DFS complexity is n multiplied by 2 to the power of n, right? Interesting. I'm wondering if this can solve the problem. Let's code this, all right? Only by coding it, we can know it for sure. So, okay. Not sure if this DFS method work, but I'll try it. Let's see. Okay. This is where we calculate the shortest path to travel all the subnodes of the current node. And here we define a n, and here we assign the value for n. Right, and here we calculate the answer. And here we try each node as a starting node. And we're going to save the main here and return answer. So the initial value should be max int. Is it int max or max int? I don't really remember. Let's try to run this code. No, it's int max. Cool. So let's implement this function. So this guy is to make sure we don't go back to our parents. Right. Interesting. Actually, we don't have to go back in the last round, right? Because when we travel this guy, this guy, this guy, and that is the end. We don't need to travel back. Oh, my bad. Okay, indeed, we need to use binary encoding here to track how many what is the nodes we already traveled, right? Okay, my bad. So basically what we need to do is to have a integer that that is in the binary form, like this, right? So each of the digits represents the state of the current node, right? For example, 0, 1, 2, 3. If the if the digit is 1 for the first node, then then the first node is already visited, right? And we need to have a array to save the current status, right? Let's say if we visit 2 and 0, what is and our current position is 0. What is the shortest path, right? So this is the dynamic programming state. The first value is the nodes that we already traveled, and the second dimension is the last node we traveled, which is the current node we are on, right? And we can calculate the next node by visit all of the current node's neighbor, right? Let's see, the node 0, which is the last node for this state, has 3 neighbors, and we can try this one. Then the first dimension will become 0, 1, 1, 1, and the second dimension will become 1 because we travel to the first node, right? And the value will be incremented by 1, right? Because we have a extra step to move from this state to this state, right? And we are going to have a priority queue to save all the states, right? Because if we arrive to a state with the minimal path, then that information tells us that since it is the minimal path in all of our unvisited states, then we can be sure that we cannot arrive at that state with a shorter path, right? That is guaranteed. So we can maintain a priority queue to store all the new states we found out, right? So I guess that's how we solve this problem. Let's see the coding. Yeah, I think that is the case. We first initiate all of those states, and we try to start from each of the node, and here we have a D queue instead of a priority queue. So I think that is because each time we find a new state, we are going to increment it by 1. So that guarantee the DQ, the DQ here is actually a priority queue because the new value will always incremented by 1, right? Interesting. Yeah, so this problem is a hard one indeed. Okay, let's move on. Next problem is this one. Let's see if anyone is watching. This is a good question. Pigeonhole. I don't really think it is related to pigeonhole here, because it is more like just a binary encoding, right? We are not actually putting some pigeons into some holes, and basically we just represent each of node has 2 states. If the node is visited, then its state is 1, and if the node has never been visited before, the state is 0, right? So yeah, it's only a binary encoding technique. Can I see this chat? I'm asking the question, dude. Can you ask your question again, please? I'm not quite understand the question. Let me looking for the word you're asking. The reach let. I'm not actually understand this word. Yeah, actually, you are asking the question. I'm trying to answer your question, but I'm not actually familiar with this Dirichlet theorem. Anyway, I think this problem is not really related to this theorem. All right. Binary encoding is quite straightforward, right? This theorem looks very complex to me. Okay, that is that. Let's move on to the next problem. Constant extra space. Let me take a look. 1 second. Which line number are you referring to? Constant extra space. Oh, is there a constant extra space constraint in this problem? I don't think so. We don't have to solve this in constant space, all right? There is no such constraint. Right? There is no such constraint. We can use n to the power of, actually we can use 2 to the power of n space, which is what we are doing now, right? And it is not really a big number. Let's use a calculator. 2 to the power of 12, right? It's less than 5,000. It's not really that big, right? I'm not trolling, man. I'm trying my best. Okay, let's move on. Split array with the same average. I really want to move this chat over someplace I can see. Huh. Okay, let's try this. Okay, this is better, so that I can see what you guys are talking about. Okay. Okay, let's try another hard problem. You are given an integer array. Oh, this problem is quite hard. I need to take some time thinking. I'll send this link to the chat so that you can look at this problem yourself. Thanks, man. Let's work together. No worries, no worries. We are all studying, right? I feels like this can be done by binary search. So basically, we can binary search the average. And let's say if we have a average value, can we find out two sets of numbers which both of them can have the same average number? I watched some other posts describe this problem before, and I made some notes here, but to be honest, I don't really remember what are these notes about. Oh, I see. Interesting. So what I did before is to find a integer k, and we are going to try each of the k's, right? And the k is the number of numbers in the first set. So basically, we are going to divide set A into two sets. And let's say the first set has k numbers, and the second set, of course, has n minus k numbers. Right? And if we pick k numbers from set A, then what are the I don't know this problem can be backtracked. Let me just try to solve this problem in my way first. All right. So first we are going to have k numbers, and with k numbers, what are the averages? By picking k numbers, what are the sums we can have? Let's say we can have a set of sums for k numbers in the first set, right? And for each sum, we are going to have an average value, right? So let's say our A is 1, 2, 3, 4, 5, 6, 7, 8, as the example says. And our current K is 3. Then our sum, if we pick 1, 2, 3, then our sum is 6. Right? And if we pick 1, 2, 4, then our sum is 7. And what are we going to do with the sum? With the sum, we can calculate the average, which is 2 here. Here is 7 divided by 3. And that means for each of the average, we can get, we can actually calculate the average of the second set, right? Because we know the sum of all the numbers, we can use that sum minus sum 1 and divide by n minus k. That give us the average of the second set. And we can compare the two average if they're the same. Oh yes, we solved this problem, right? So Here is how we're going to solve it. First, we are going to iterate each of the k here. K can be 1 to n. If k is 1, then the first set has one number and the second set has a -1 number, right, etc. K is the number of numbers in the first set. And for each of the n, we are going to find out how many sums we can have for k numbers, right? So in this case, we have 8 numbers. So we are going to we are going to iterate all those combinations and find out the sum of k numbers. There are quite a lot of combinations we are going to have, right? And let's forget about the time complexity for now. And for each k, we are going to calculate the sums of k numbers. Let's say we pick k numbers from the set, and what are the sums we are going to have. And we are going to put those sums into a set. We call it a sum 1 set, right? Because this set contains all the possible sums in the first set, right? And for each of the sum, we can calculate the average for the first set. We call it average 1. And also, we can calculate the average for the second set, right? By just deduct the sum of the first set from the total sum, right? And divide it by m minus k. That is the average value of the second set. And we can compare these two values. So that's how we solve this problem. The problematic part of this solution is that we are going to find out all the possible sums created by k numbers. And if we use the normal method, that's a complexity of 2 to the power of 30, right? Because we are going to pick k numbers. So that is choose k numbers from n numbers, right? So that's quite a lot. Let me see what is the what is actually the value of 2 to the power of 30? Wow. No, this cannot be handled by LeetCode. Interesting. Let's see how do they solve this problem. I give up, right? This complexity is too large, seems not solvable. Hey man, actually I'm not really trying to teach. I'm just trying to learning. Let me see, what is your question here? Can you emerge to impact you in Google? No, don't know which how it is called. I'm in one of the flag company. Yeah, this problem is actually hard. Right? Can you emerge with black box problem? Or it may be easy. Do you know what is binary encoding? I think you stuck with binary encoding there. So I think you can find some material by searching binary encoding online, right? And in this session, I'm not really trying to teach people because I'm kind of feel lonely when I just read the materials and trying to grinding all the problems. So I put my session here so we can just learn it together. So sorry about that if I didn't do a great job to teach you guys how to solve a problem. Because my goal is not to teach, is to study together, right? So bear with me if I cannot answer all those questions. My primary goal is to solve the problem with some help from the online materials like this one. Let's see, it's in Chinese. Sorry if you cannot read it. Okay. Oh, 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 okay. Interesting. Oh, actually, oh, this guy in this post, he actually used dynamic programming to just calculate all the possible sums for the first set. So basically, we have a we have n numbers, and we are going to pick k numbers from it. And the goal is to calculate how many sums we can get from k numbers, right? And what he does is that he uses dynamic programming, and it's a two-dimensional dynamic programming. And I says we are going to pick j numbers from the first I numbers, right? And this set is the number of it's all the numbers that we can it's all the sums that we can pick j numbers from the first I numbers, right? And we can the goal is to calculate some k, right? So this guy means we are going to pick k numbers from the first n numbers, and this is the set of the sums we can get from the k numbers. And to calculate the this value, we are going to deduce it from all those previous states. And the initial state is that we pick 0 numbers from the first 0 numbers, and this set is now empty, right? And we can deduce from this state, we can transfer it from this state to another state by adding a new number, right? We add the one more number to the set, and we can either pick it or not pick it. And if we pick it, that means we for each sum I and j, we are going to iterate all the possible values in this set, and each of the values can be added by a new value, which is a I plus 1. This is the new value we are going to add to this set. And we can add this new value to the next state, which is I plus 1, j plus 1, right? And we can also do not pick this new value and add this value to I plus 1 and j, right? Actually, what he did is sum ij equals sum I minus 1 j join sum I j minus 1 plus aj. Our method is actually the same, right? So basically, he calculates the results by joining these two sets together. And what I did is to put one more value to the new set. And we're going, for each old set, we're going to put the value into two new sets. So these two ways are equivalent, right? Cool. So that is set. And for each sum, cool. Okay, so that is that. This problem is quite intensive, very hard. Yeah, we might need to review it very soon. So basically, this problem, we need to calculate the possible sums of if we pick k numbers from the original set. And by picking k numbers from the origin set, we already know what is the sum we are looking for. Do we? Let's see. So here I is our k, right? And the total sum is the sum of the original set. And if we have a total sum and we total sum multiplied by I and divide by n. What does that mean? Oh, I see. So basically what he did here is he did some translation, right? Because total sum divided by n should be equal to subsum. I mean sum 1, the sum of numbers we pick for the first set divided by I, right? So we pick I numbers for the first set and we divide it by I. And that means if we move I from this side to this side, that's multiply, right? And our goal is to find this sum for the first set, which should be in the set we get from the dynamic programming, right? And in this case, he is proactively looking for the target sum for the first set. Yeah, that is genius. Cool. Nice problem. If I am asked this problem in the interview, I might fail. All right. It's very hard. Okay, let's move on to the next problem. Before that, I'm going to take a break. So see you guys soon.